Thank you very much. Can you all hear me? Is the mic working? Excellent. Well, thank you to GMRI for having me. It's a pleasure to be back, and thank you all for coming indeed on this beautiful night. Our spring's been much delayed, so I appreciate your sacrifice to come out and hear about the oceans. I want to talk just a little bit at the outset about how I came to report a great deal on oceans issues and ultimately write my first book on them and continue to follow them. And a lot of people become surprised when they say, when Ocean's End first came out in 2000, people would say, well, why did you come to write a book about the oceans and the problems in them? And they're often surprised to learn that the origins of that actually started when I was living in landlocked Hungary. And I was there in 1989 as an exchange student and watched the collapse of communism, and then was there for a number of years thereafter, covering the region for some of the newspapers previously mentioned and the transition there. And oddly enough, although I was covering a wide variety of things, the actual transformation from communism to something else, and the carpetbaggers who were coming in, and the building ethnic conflicts between Romanians and Hungarians in Transylvania, and between Croats and Serbs in Slavonia and in Bosnia, and so on and so forth. But oddly enough, the sort of plurality of the reporting I was doing tended to be on environmental issues. And the reason for that is because environmental issues weren't something periphery there at the time. In 1989, 90, 91, environmental issues were staggering and unavoidable problems. I mean, really staggering. Because the Eastern Bloc, the Soviet bloc, had never had a Clean Air Act and a Clean Water Act. And if you'd like to see what the world would be like if you'd never had those things, go back to your time in Newsweek covers from about 1990 of the terrible environmental mess in Eastern Europe. Because it was, the externalities of pollution from factories or what have you would be released directly into the environment. That's some toxic waste, dig a big hole and dump it into the hole and then cover it up and keep no records. And so on and so forth. So the problems were quite bad. I mean, Kopsamica, there was this town in Transylvania, and you knew you were approaching this town from a great distance because starting miles and miles away, all the landscapes started turning black. And the trees were turning black, and the houses, and the people, and started approaching this enormous smokestack of a carbon black factory that indeed released its sort of coffee toner-like effluent straight out of the flue, and it would land on the landscape, and it dyed everything, including the people, in this carbon black color. It was known as the Black Town, and indeed made the covers of Time and Newsweek. There were times where, I remember being in Krakow, which is a beautiful city like Prague. You should definitely visit Prague without the same crowds, a more intense sort of, J.R. Tolkien kind of experience of Europe, with lots of, tombs and knights and history overflowing everywhere. But all of the gorgeous architecture was melting away from the acid rain from the nearby steel mill, again, because there was no controls on things. People said, don't go out at night because that's when the worst emissions are. So everyone stayed indoors at night and closed the windows. Don't use the tap water because it dissolves metals, it's advised. Town in Slovakia, you're heading from my guest house, a beautiful little medieval town of about 5,000 out in the middle of the mountains. And I remember going from the restaurant I'd just come out of at night, and there was a dip as you went over the little medieval bridge and back up on the other side of town where my guest house or hotel, wherever I was staying, was at. I remember walking down there, it was a beautiful night, and then suddenly entering a cloud of some kind of unbreathable toxic stuff. I literally couldn't breathe and having to run up the other side, barely making it before passing out. What it was gathering in the hollows, who knows? But the key is that the pollution problems were that bad. Well, we ended up covering a lot of them, and a lot of us clever journalists who decided we would think big and frame these things at an appropriate scale started looking to the Danube River. Now, if you live in Budapest, you can't avoid the Danube River. The bridges all cross the Danube, everything from the radio stations to the in-flight elite frequent flyer program of the Hungarian National Airline were all named after the Danube. There's a blue Danube waltz. This is no escaping the Danube. And there it was flowing through the city, and it was terribly, terribly polluted. And it was polluted because all the countries along its enormous watershed, which is 1,800 miles long and with all its tributaries encompassed 10 countries and drained about a third of all of Europe, all of it, once you reached the border between Western Europe and Eastern Europe, beyond Vienna, as you headed downstream, suddenly there were no pollution controls. For instance, Budapest, where I was living, 2.5 million people, essentially released all of their sewage through tertiary treatment, meaning they screened out the big stuff and then it went right into the river. Bratislava didn't even have that. All of it went in. Same with Bucharest, 2 million people. With Belgrade, 2 million people. In fact, with every single town and village throughout the watershed, there was no proper water treatment of the sort we would consider. It was all just going into the river system. Also, all of the toxic effluents of whatever industry were there were also going in the system. And here was the thing that made this story so intriguing and becoming a metaphor for East and West and the thawing out of all the long-delayed historical problems of the region, was that people were using, all these countries were actually enemies of one another. They've been forced to do a fraternal socialist order, but in fact had thousands of years of beef with each other, and they were starting to take it out via pollution. Even in the communist era, you would take the most polluting factory you had, and you would, place it right on your border, just upwind from your historic enemies. So all the pollution would go there. But your enemies would then, station their factory on your river that went down. And the Romanians at one point, who hate the Hungarians, released intentionally an entire cyanide-laced tailing pond from a mine into a tributary because they knew it would flow right into the river heading down to Szolnok, Hungary, where all the alarms went off to inform them the cyanide went there. So all of this kind of stuff was happening. What a great metaphor for a fractured continent and for history coming back alive, the rebirth of history, not the end of it. And in order to cure all these problems, you would have to get all these countries, East and West, Balkans and Eastern Europe, Habsburg Zone and Ottoman, to cooperate. What a great story. All us journalists who covered it felt extremely clever. But here's the thing. None of us were actually thinking big enough. Because through all of the ink that was spilled on the problems of the Danube and the efforts to clean it up, none of us, it ever occurred to us to ask the rather obvious question, where does all the pollution in the Danube end up? Just kind of never came up. And the answer is, the Danube goes all the way through Eastern Europe, and it ends up in the Black Sea beyond Romania, right? A sea the size of California, kind of kidney-shaped. It's the one that you have to go through the straits by Istanbul, the straits in Turkey, to get to, and then you go out to the Mediterranean. That was the Black Sea, and unbeknownst to anyone, because nobody was thinking about it, it suddenly, in 1993 and 1994, underwent an unexpected and unforecasted, almost complete biochemical collapse. Everything essentially died, leaving a sea of slimes and jellies. But what on earth happened, and how could everyone have missed it? Well, the Black Sea and the relationship with the Danube kind of tells us a lot about the problems in the oceans generally, and the fact that we all missed it, and why we missed it, and what the different sectors are. Because the big problem with the Black Sea, the big scary driver of all drivers, was a kind of pollution that didn't even seem that scary. You can say it, nutrient pollution. Whoa, nutrient pollution, right? Doesn't sound that bad, but remember all of that, all of the sewer and stuff going into the river systems from all of the people in cities and towns and villages of the region were all going into the river and flowing downwards. And indeed, all of the agriculture, much of which was collectivized in Eastern Europe, there were incentives in the Soviet system to maximize production, right? If you ran a factory or you ran a collective farm, you had a 5-year production target. If you didn't meet it, woe be unto you. Everything was all about maximizing production, and nothing else mattered, especially since your inputs were essentially free to you. And the inputs from the Soviet Union of chemical fertilizers came in huge amounts and were free. So what did you do? If you were a manager, you threw as much fertilizer as possible. You cleared out every tree until you reached the bank of a river, and you planted all of it because there weren't any incentives not to. And so all of this excess fertilizer was flowing straight into the river, and things were eroding. In other words, there was this huge bomb of fertilizers and nutrients of different sorts coming down the river. And this is problematic for this reason, because in the oceans, right, the base of the food chain is plants, just like on land, except most of the ocean's plants aren't the seaweeds and stuff you see on the bottom, because things get too deep pretty fast for the plants to get enough light. Most of the plants in the ocean, the primary productivity, come in the form of microscopic plants. Marine algae and some of the other creatures you see up here on the board. Those are the meadows, essentially, of the sea. And they have everything they need in seawater in essence, except the big restriction on their population is they're lacking nutrients. The phosphorus and nitrogen that are kind of the basic fertilizers are usually the control available. Why? Because when things die and would give you nutrients to feed your plants, they tend to fall with gravity down to the bottom. And guess what? Light tends to not be on the bottom. So the plants need light and nutrients in the same place. So oftentimes if there's a place where currents bring stuff up from the bottom, upwelling, that's where you have incredible fisheries because the fish are coming attracted to all of the algae ultimately at the bottom of the food chain that's providing for them. People were suddenly providing a staggering amount of food for marine plants and algae. And it was all coming down the river, and there were normally a number of ways in which the river would filter itself. There were these natural sponges and cleansing systems, which were the wetlands. There were internal wetlands in the river around the Hungarian-Slovak border south of Bratislava. There was a huge one. There was historically a very large one between Romania and Serbia as you went down further down the river. And the grandest of all was the Danube Delta, an enormous wetland, kind of like the Mississippi Delta country, that was the great filter right at the end before it entered the Black Sea. But over the previous decades, first Serbia and Romania built a gigantic dam together, the Iron Gates, that flooded and eliminated that wetland. And then, in the very middle of the 80s, the Hungarians and Slovaks started building a dam that destroyed and bypassed the wetland in that area. And finally, Nicolae Ceausescu, the mad dictator of Romania, among his many crazy schemes to increase Romania's greatness, was to decide that he was going to attempt to grow rice in the Danube Delta. He would do this by taking the Danube Delta and draining it for rice paddies. Of course, once he did that, saltwater intruded and killed all the rice, but he did succeed in destroying much of the wetland and its filtering capacities. And those things put together seem to have driven an incredible explosion of nutrients, a doubling of one type and a quadrupling of another. And what happened? Algae blooms like you wouldn't imagine. Huge ones. You know when you have a pond, right, and everybody's still flushing their waste into it, and you get an algae slick there, and everything starts dying in there. There's not enough oxygen, the fish die. You get a slick of algae on top. That was kind of happening at a scale of the entire shelf areas of the sea. All the places where you might have, shallow enough for light to penetrate to the bottom, the places where life comes and gathers, those were the places that were also adjacent to where the nutrients were coming in and triggering blooms so thick, such enormous amounts of plant life that the things that eat them, the grazers, the little teeny, animals, the zooplankton and other things that would eat them, couldn't keep up. And generation after generation, pile after pile of algae fell to the bottom. Well, nature has a way of taking care of uneaten food. Just like on land, you end up having bacteria that will break it down. Great, except that the process by which bacteria break down organic matter requires oxygen. And the bacteria strip the oxygen, the dissolved oxygen, out of the seawater around them, which is problematic because remember all the creatures with gills, fish and everything else, are filtering oxygen. They're actually breathing. If they don't have oxygen, they're in trouble. And so much of the algae was falling down that bacteria were actually stripping all of the dissolved oxygen from vast areas, creating dead areas where anything that couldn't escape died, and it disrupted all of the migrating patterns. This fish is planning to come down here in the spring and eat this fish, and suddenly it can't get there because there's all of this dead zone of water in the way. And this thing is supposed to show up here to lay its eggs, and it can't get where it's going. There was this great disruption going on that was becoming extremely difficult. Then the algae slicks were so thick that all of the plant life on the bottom was starting to be suffocated for light and also disappeared. In other words, everything was starting to fall apart all at once. Now, we've talked about a few factors, right? Who's killing the Black Sea? You got municipalities in many different countries that don't agree with one another, some hundreds of miles from the Black Sea upstream. You have farms, and you have a third factor suddenly come in that nobody was quite expecting: shipping. Remember, all these things were regulated separately in different silos. municipalities and farms to have different ministries of agriculture and this and that. We think about them separately. We think about their impact separately, especially if they happen to be in different countries. One's in Hungary and one's in Romania and one's in Turkey and so on. They have no way to cooperate. Well, the shipping industry operates almost on an international frame. And the big problem with the shipping industry, and one that ended up affecting the Black Sea, is that, when you see oil tankers coming into Portland, and they unload their oil, or at least they used to unload their oil here, you would have, as they unload their oil and the trim of the vessel would come up, right? It would start because if the vessel weighed less, it would rise more and more in the water. You can see the boot top saying, 10, 15, 20 feet, that it's way up above its normal depth. So what do? You can't go out across the ocean riding that high in the water. The ship would be unstable. So long ago, mariners solved that problem. You have ballast tanks, and you just pump in enough seawater to bring your trim down to a safe level so that if you're running empty, you can return back to the next port and do it safely. Problem is that some of the creatures that are in the water you pump in actually survive going through the pumps, particularly some of the smaller ones in eggs and juvenile forms. And some of them actually survive the multi-week voyage to wherever you're going next. And a tiny subset of those actually survive being pumped back out on the other end. And usually they're in trouble because the environment they encounter is inhospitable to them. And there's all these competitors who've been involved to it, and they usually don't have such a good time. But if they happen to arrive somewhere where the ecosystem around them is already sick, a sick host, where the normal ecosystem is disrupted, every once in a while, one of them is able to move right in and take over. And this is what happened in the Black Sea. In the middle of this great catastrophe where the ecosystem was weakened, a passing freighter, indeed, from the east coast of North America happened by and pumped out somewhere on the shelf off Bulgaria and Romania one of those, comb jelly, Monopsis comb jelly. They're small, they're about this big, they're sort of jellyfish-like creatures, shimmering looking, actually quite beautiful, not all that threatening. However, they ended up encountering an environment they really, really liked. There may have been, one comb jelly released. But over the course of just a few years, there was the largest explosion of a population of an organism that scientists have ever seen. In a few years, it went from perhaps one comb jelly to 1 billion metric tons of comb jellies. 1 billion, like Dr. Evil. What does that even mean, right? Well, to put it into perspective, that's equivalent to 10 years of all of the fish that all of the world's commercial fishermen catch. That's how much comb jelly was suddenly in the Black Sea. A staggering, staggering amount. And unfortunately, comb jellies do not eat the algae slicks. They eat the tiny animals who would normally be eating the algae slicks, which only made the situation worse, which is how you ended up in that catastrophe that we all suddenly realized in 93 and 94 of an entire sea that had been converted into jellies and slicks. My gosh, well, that got my attention and many other journalists and covered that, and it was surprising, rather distressing. How could you have a sea the size of California that has nurtured civilizations from the ancient Greeks onwards? How could you have it be destroyed like that and nobody even knew it was coming? How is that even possible? How could we destroy entire seas, it seemed, in the early 90s? Is this indication of something worse? That humanity is now getting powerful enough to disrupt entire large marine ecosystems, like the rainforest. This seemed like a strange, intriguing, and haunting idea in the early 90s. And I happened to be going home around then. We started hearing word of the Grand Banks catastrophe, where off Newfoundland, where the largest and most important cod fishery ever known to man had collapsed by 98.9% from its historic level of the 1960s. And then a couple of years later, the catastrophe on Georges Bank, nearly as bad, with large reductions of ground fish. What could be going on? Shortly thereafter, Spain and England, as the European Union was starting to form up and fisheries were starting to become unified, we're suddenly having Spanish and UK fishing vessels intruding into waters where normally had been national waters previously, having to be escorted by naval frigates because they were attacking each other over the squabbles over the few fish that were left. So I ended up doing a project when I finished up in Eastern Europe and came back to the U.S. and was based in Washington. And I started exploring that. I started traveling around the world doing a big project to look at large marine ecosystems and crises that were happening to try to answer that question. What is going on, and could it be that we're actually disrupting the oceans at large? And I traveled all over the place then. I went to Belize, learned to scuba dive there, to the Barrier Reef there, which is the largest in the Western Hemisphere, which happened while I was there to undergo the greatest coral bleaching event in history at the time. Coral bleaching is corals are a plant/animal essentially. The corals are growing and they're made of limestone, and the creature that is growing is a little sort of anemone-like creature, but it also has all sorts of plants kind of symbiotically living within it, so it can kind of do some photosynthesis even as it goes and grabs food. Well, if the water gets too warm, and water temperatures were getting warmer and warmer, and especially if you also have some pollutants going, the corals will expel their little chlorophyll plants that are living within them, turning the corals white. The color of the corals is correlated to the organisms living within the anemone-like creature. And this was happening all over the place, and they tend to be much weaker and sometimes die as a result, going over entire areas of once pristine coral that were all turning white. Well, this was a kind of a distressing problem because, unlike a lot of other places that have all kinds of exposure to pollution where you'd see coral bleaching, the areas that we were going way out on the outer parts of the reef were far from any obvious concentrations of pollution, which made it even of more concern. I went to Newfoundland and saw what the fisheries collapse was doing to a place that's it's kind of an extreme version of Maine. If you take the Maine's ethnographic heritage and its colonial era dependency on the sea and amplify it 50 times fold, you get Newfoundland, where people have been living since has been colonized since the 1580s and 1590s entirely in the pursuit of cod, and that remained the same all the way through the early 90s when I was there, when suddenly the cod was gone, devastating the only real form of income and the way of life of hundreds of rural outports up and down the island. I went to Antarctica because it was beginning to be evident that climate change might actually be happening. It was being predicted it might happen, but you might actually be seeing effects in the Antarctic. I spent 6 weeks there with the National Science Foundation doing reporting on a ship that was tasked with going out to the Weddell Sea south of the tip of Chile to look at the ozone hole, and then went on to one of our research stations where all of the glaciers of 10,000-year-old ice behind the station had been slowly scrolling back season after season. You could see it because they had the photographs, kind of like the Dharma Initiative or something from Lost. You had all the photographs of the crew of the Dharma Initiative each year. If you go back to 1968 or 1959, there's the crew, and you can see it hair styles change, and the ratio of men and women at the base change, and the outfits change and get really ridiculous in the 70s. But also, they shot it at the same place behind the station each year with the glacier behind it. And in the first shot in the 1950s, the glacier's right behind them, and you can see it shot after shot moving back until it's way back out there in the distance. Remember, 10,000-year-old ice left from the last ice age. And meanwhile, the scientists who were there were watching the creatures they'd been studying in long-term ecological series. We'll understand how this ecosystem works. We'll study it for 2 centuries and understand it because it doesn't change except in geological times. We're seeing in the space of a few years the Adelie penguins they studied start disappearing from the range, in part because ticks were starting to survive the winter because the winters were getting warmer and warmer, and penguins do not have any response to clean each other around the necks from ticks, and the ticks could actually bleed many of the penguins dry. The ticks arrived with storm petrels and stuff who sail great distances. Needless to say, people were rather shocked that this was going on, and again, it was another place for concern. Went out to the Marshall Islands in Micronesia and the blank face of the Pacific, places that are all atoll states, where the entire country consists of hundreds and hundreds of islands, thousands of miles from any mainland, and the islands are basically the tops of volcanoes. Remember, you have a volcano in Hawaii. You know how the Hawaiian Islands, the newest island's the Big Island. It's active because as the plate moves, it's been moving over the hot spot, and the islands get smaller and smaller as you get away from the hot spot because the islands have been, since the volcano went away and they weren't active, it starts falling into the sea. Well, if you keep going and you fall into the sea and the last bit falls, the thing is that around the edge of that collapsing, disappearing island, eroding island, there are corals that have formed around the island, right? But they keep growing, and as the thing collapses, they keep up. And so what you have left is a ring of living coral and all the sand it produced that's perched on the top of a disappeared volcano. This entire country was just rings of coral and sand. The whole country was 4 or 5 feet above sea level. If sea rose the way people were predicting then, they realized that their country would disappear, and many of them believed it was already happening. So to make a long story short, so I also went to Louisiana and the Gulf of Mexico, where a giant dead zone very similar to the Black Sea was forming for very much the same principles and reasons at the mouth of the Mississippi each year. So, needless to say, Ocean's End was discovering that indeed we were disrupting large marine ecosystems and continue to do so. And since writing it, unfortunately, the situation has actually gotten worse by any metric. At the time, nobody was quite sure if the warming that we were seeing and the sea level rise we were seeing, the warming we were seeing in Antarctica, could it be that was just that Antarctica is finally caught up to the end of the Ice Age 10,000 years ago. Finally, that warming trend has reached them, and then there'll be a shift back. That was the prevailing theory, because, hey, look, in the Arctic, in the North Polar regions, we're not seeing any change at all. And then the opposite happened. It accelerated in Antarctica, and it accelerated in a degree that just has stunned everybody in the polar regions, and it's since been discovered that indeed accelerated climate change is happening, that the Marshall Islands are probably in a great deal of trouble. I went up there. I was in Greenland in about 2008, traveling around the country. The disruptions to Greenlanders, they are Inuits. They've been there, forever. They speak the Inuit language. They're part of sovereign territory of the Kingdom of Denmark, but they essentially are self-governing and stand on the precipice of full independence. However, there's only 56,000 of them. They're strung on this island up to the high Arctic. And in the northern parts, the basic way of life is that the terrain is so crazy mountains and glaciers, that you can't build roads. There are no inter-town, intercity roads in Greenland, because to get from one hamlet of 500 to another, it would cost you like $10 billion to run tunnels through the mountains. So there's never been any roads. You can't get from town to town by them. You can go by sea in the summer, or for long distances, you essentially have to travel by helicopter, which is enormously expensive. So people are kind of stuck all summer. But in the winter, the sea freezes, and you get out your sled dog, your prize sled dog teams, you ride everywhere, and that is just what everybody does. As one Greenlander told me, if you're the guy with the really great sled dog team, you're that guy. It's that important. But as the climate was suddenly changing, the sea ice was not forming solid anymore. It was breaking up constantly, creating crazy landscapes you couldn't sled through. People were trapped, and several years had gone by, and they were starting to eliminate their sled dogs that have been the basis of their culture for thousands of years. Whereas in the south, in the southern parts down where Leif Erikson had first arrived into the fjords, and the Vikings had been at one time, that year that we visited a man who was growing broccoli for the first time in Greenland. So great transformations were happening. And then there were starting to be new factors that have happened since, as I followed the ocean stuff. Not only has the climate change factor become certain and a major driver of everything else, but we're starting to discover other things that nobody even had thought of when Ocean's End, when I was researching that at the end of the 90s. Among them is ocean acidification, because one of the effects of the extra carbon dioxide being added to the atmosphere is that a lot of it gets absorbed by the oceans. And the problem is that one of the effects of that is it actually changes the pH value of ocean water. Well, it doesn't change it a lot, but it changes it enough so it starts affecting the ability of certain shell-growing organisms and certain things like corals who grow that limestone. It starts affecting their ability to grab the things they need out of the water and assemble their shells. And this was first discovered. I was in Grenada, the island in the Caribbean, doing a speaking thing, and the speaking was a great little junket. In addition to bring me down to speak, we would go out diving, and a lot of the people turned out to be a group including Buzz Aldrin. I went scuba diving with Buzz Aldrin and a bunch of other NASA astronauts. And I was assigned, though, I didn't know these people, so I was assigned randomly to a dive partner, and we're going out on the boat, and we got in the interval, and we're talking, a lot of people are oohing and eyeing about Grenada's corals, but these aren't as cool as the Micronesian corals. No, they're not. Yeah, we've been to the cool diving places. But, all these problems are starting to happen. We see everything out. Yeah, I said, we see the bleaching. Yeah, and then there's this ocean acidification thing. I mean, who threw that into the mix? And the guy got this funny look. He was looking at me. And he says, "You don't know who I am, do you?" I said, "Not really." And he's, well, it turned out that, remember Biosphere 2? Remember the project out in the desert? They went out in Arizona and they said, if we're ever going to go to Mars, we're going to have to figure out how to have a self-enclosed ecosystem that will support humans, right? A giant habitat where you can somehow keep everything under control, so you grow your own food, you keep your own air, and you get rid of your waste products. We'll try it right here in the desert. We'll seal a bunch of people in for, I can't remember, 2 years or something. You'll all live in a habitat hermetically sealed off from the rest of humanity, and see if you can pull it off. We'll have a little rainforest in it. We'll have a cool reef tank. We'll have agriculture, and we'll see if you guys can manage to keep the system in order. And this was one of the guys. This guy was one of the people sealed in there for 2 years. He's one of the bionauts, right? And his job was to take care of the coral tank in the ocean. And of course, what defeated Biosphere 2, and they had to abandon it early, was they couldn't control the carbon dioxide they were breathing out. They couldn't get rid of it. Pretty soon there was so much carbon dioxide in the air, it was going to kill them, and they had to abandon it. Essentially, they had the same problem that the Earth is now having through the burning of fossil fuels, although they weren't focused on that at the time. And one of the things that was happening towards the end, when the CO2 levels were going absolutely through the roof and they're getting close to leave, is he started noticing that the corals in the tank were starting to dissolve as a result. He was essentially the guy who first encountered and ran into ocean acidification. So I say all that in that there's a long preamble and a worrying set of things that have been happening to the oceans, and also in the Gulf of Maine, the recent Press Herald series. How many of you read Mayday and read the Press Herald series? Most of you have. We can talk questions about it. But in essence, the situation in the Gulf of Maine is that for various reasons, we're warming particularly rapidly. In fact, Andrew Pershing, the chief science officer here at GMRI, is the person who has published the data and such, really focusing on this problem, particularly that there, over the 10-year period ending in 2014, the Gulf of Maine actually was the second most rapidly warming place on the entire planet. Now, that's a temperature spike. It's an anomaly in a longer, slower projected time series, but the key thing is that spike gives you a advanced look at the future, is one of the things it does. Because if you play out that spike and you look at all the projections as to how the Gulf of Maine will warm, we're going to be up there in that spiky zone, which got at the very top in 2012, that crazy warm year where the ocean heat wave happened and people started seeing blue crabs showing up in Nova Scotia, and squid are laying eggs in the estuaries in Maine. And green crabs were starting to explode in populations and eat all of the clam flats and destroy all the eelgrass in Brunswick and Yarmouth and other places. All of these strange things were happening. It's all a snapshot of what the conditions, prevailing average conditions, will be in about the year 2050. So you're getting a look, not very long down the road anymore, of what the ecosystem is going to be like, and it's very disruptive because all kinds of other factors described in Mayday are at play, because many of the species that live here are at the southern ends of their range. They're cold water species relying on currents and stuff that come in here that may not be able to tolerate those changes and may leave the area, and warmer water creatures will start moving in. It won't be necessarily as productive a system. So there are many reasons to be concerned about it. What do you do about all of these problems? What's the essential thing that people ought to be doing for the oceans at large or the Gulf of Maine? Well, my conclusion has been that one of the big problems that we've always had is we have never really understood in the past how these ocean systems work. There's sort of this assumption that you could take as much as you want out of the ocean and put as much as you want in, and everything would be fine because the oceans are so big. And besides, we can't really see down there, and it's incredibly expensive to send a sub down, and it's such an inhospitable environment. How would we ever figure out how those ecosystems work? And so we didn't really know. Well, we need to know now, because it turns out that we are able to destabilize these systems, and we don't really understand what the important parts are. Because if you shore up these systems, if you figure out a way to not wantonly damage them, they can stand up to a lot of things that if you're damaging them, maybe they won't. Maybe you can have a system that will be relatively healthy if, say, climate change or something that's much harder to control at this point starts affecting them. A healthy system will do much better. Just as the Black Sea might have been able to resist the Monopsis comb jelly if its ecosystem hadn't been disrupted, because undoubtedly ships have been pumping those out for decades. It was only once the ecosystem was damaged, they were able to get a toehold. So how do you make things more resilient? First, you need to understand how the system works so you can figure out what the important parts are. And that's something a lot of scientists have been looking at. There's this idea of ecosystem-based management, not that you can manage the whole ecosystem, but perhaps you can understand and figure out enough of the parts to figure out what the important rivets are that you don't want to mess with in order to avoid calamity. So understanding those things is important, and then from that knowledge, reducing unnecessary stresses so that the system can respond. And the good news is that ocean systems are sometimes surprisingly resilient, because that whole story with the Black Sea actually ended up with a happy ending. Despite everything that happened to the Black Sea, it had the good fortune to have happened at a time of a great historical change. The collapse of communism in Eastern Europe was followed by the absorption of most of the countries in the Black Sea watershed and the Danube watershed by the European Union. And when the EU did that, when some of the most advanced and environmentally conscious and rigorously regulated countries absorbed that region, they required that that region achieve their environmental and pollution and municipal waste standards, and they invested billions of dollars in order to do it, and all the agriculture sector had collapsed. So the pollution had actually went way down with the collapse of agriculture. Municipal waste treatment plants were put in, all of the stressors were reduced, the nutrient levels went down, and lo and behold, the algae blooms started to disappear somewhat, and the ecosystem started to recover a bit, and then another comb jelly showed up that liked to eat the first comb jelly. Passing freighter said, hey, there's an awful lot of these jellies around, and proceeded to eat them down, and having run out of its favorite food, its population collapsed as well. Probably solved. So it's a lucky historical circumstance, but the Black Sea may not be as productive or as good as diverse as it was, but it's recovered to a degree that is actually rather surprising once you stop messing on the stresses. So the doom and gloom of what we're doing is not necessarily, there can be a feedback mechanism that's helpful. Maybe the system won't be as good as it was before we were messing around with it, but there are things we can do to help it respond once we have the knowledge. So I'm going to stop there after that voluminous intro and open it up to your questions.